Morning, everyone. Great to be here. First time at TechBBQ. Does it sound okay? Okay. I didn't realize there was actual grass outside. It's quite amazing. My name is Greg. I'm head of partnerships for AR, VR, and Lens. We'll get into that, what that means. My goal for today is really just to give you a high-level idea of how we think about immersive computing, what that actually means, and explain a little bit about in detail some of the projects that we have in that field. The clicker doesn't work. Oh, great, thank you. So the thesis here really is, how do we make technology such that, first of all, it gives us superpowers? That's kind of intuitive. I think that's sort of how we think about technology anyway. And then how do we make it work like we do? So the image here is of punch cards from 1940s. And if you think about it, that's not the most intuitive way of getting things done, right? It's kind of abstract as a form of input. So, thanks. That's okay. So then, taking it one step further, you could say that actually the first real breakthrough in computing interfaces came with mobile phones and touch screens. And that's true, but still there's a layer of abstraction, right? So like when you have a video call with someone on a smartphone, you don't actually see them as you see somebody in real life. You see a 2D flat version of them. So this kind of level of abstraction remains. And if you think of innovation curves, and what the next computing platform could be, our thesis is it's kind of moving into this VR and AR curve. And still we're right at the beginning of it. Another way to think about this is, smartphones have become consistently more powerful over the last 10 years. And I think that's true across the board. And yet, if you think about this, they are pretty much blind to the world. Like, the phone sits in your pocket. It doesn't know where it is, really. I mean, it knows broadly where it is, but it doesn't really know what's around it. It's not contextually aware. It's not that smart, actually. And so, yeah, phones have become way more powerful, but they're not really truly smart in the sense that we think of what smart could be. So when we think of immersive computing from the Google point of view, there's kind of a few building blocks to that we, I think, are really important to make this future come to life. So our investment into Assistant, Google Lens, AirCore, and Daydream are kind of all these building blocks that are really important at this foundational stage of what we think of as immersive computing. So I will talk primarily about Lens and AirCore. And Lens is a new initiative, a relatively new initiative. Did anyone raise a hand? You've heard of Google Lens? Okay, cool. There's quite a few. Awesome. So yeah, the high-level narrative for Lens is pretty straightforward. It's basically search what you see, and obviously interact with that world around you. And I think this is really juicy because if you think of Google search and Google's core product, it's been around search. It's been basically like, searching the web. And the web consists of text and images, so you can index that and you have Google search in the web. This fundamentally shifts the paradigm to essentially making everything else searchable, making the world searchable. And this is really, really interesting and really challenging, obviously. So we'll get into that and what this actually looks like. The problem is really difficult. Think about voice. Voice in itself is already quite challenging. Does anyone know how many, roughly, words are in English language? Any guesses? Huh? So there's around 180,000 words in English language. but we, on average, use around 3,000 of those. So that's already quite difficult with assistant and voice to make that work really well, even though the problem scale isn't really as challenging as with images. There's upwards of 1 billion things in the world. 1 billion. And if you consider modifiers like orientation and lighting and various other aspects, the number of these potential permutations increase exponentially. So this is really, really difficult. Can we go to the next slide? Oh, there we go. So it's kind of a difficult challenge, actually. So you probably cannot tell that where is the Chihuahua and where is the muffin. Yeah, I mean it's pretty straightforward. But computers still tend to trip up at some of these really simple problems, and it's okay. But obviously we're getting this. Actually, we're getting this a lot more accurate and a lot better over time. And right now, it's not much of an issue at all. Chihuahua, muffin, straightforward. However, this is just the early stages, right? And the way we think of lens, there's really four components to sort of that underpin the infrastructure of how lens works. So peeking into this a little bit, there's basically four of these, right? With classification, you're essentially letting computer understand what the object is and assign a probability to what that object is, and then that actually then in turn helps to train the model further by improving the accuracy of detecting certain objects. The next stage is detection. And detection is where you start to get into the semantic understanding of the scene. So understanding where certain objects are and why they might be important to you. So actually understanding what the scene is, so that that the cake and a boy probably means a birthday, rather than them just being disconnected objects. Embeddings is another way to basically ask the question of what is distinct about the image. And this becomes really important when you try to understand essentially what are similar images. So I'll explain that further with an example we have with shopping. That becomes really, really, really important. CPUs, TPUs. So obviously hardware drives a lot of the innovation in model training. And with custom hardware units like the TPU, which is a tensor processing unit, we can really accelerate advancements in model training by, exponentially pretty much. So if you think about this right now, some model training problems can take weeks to even months of typical kind of GPU time. With CPU, we can improve that and bring it into basically the number of hours to complete. So that's an amazing increase in efficiency. So how do these actually apply to lens? So the first one is a pretty straightforward example, but I think really powerful. So smart text selection enables you to take text from the real world, whether it's a sign, a menu, or like a book, a business card, anything else, and make it basically interact with so be on your phone. You can copy and paste. In this case, you can actually search directly from the menu. If you don't know what paneer is, you have a card come up here that actually gives you a little preview. You can go into Google search, Wikipedia article, and tells you more about what that is if you didn't know. And in practice, this looks a bit more like this. So you can basically point your device at any text, and there it is on your phone. That's pretty cool. There we go. Equally, you can learn more about landmarks. So walking around a city, not knowing what something is, thinking the use case is, okay, I'm here at this building, kind of find it interesting. I don't know how to describe it in Google. you can probably go into maps and figure out where it is and then search for it. This way you can simply point your device at pretty much any landmark and learn more about it. Like in this case, you learn that Coit Tower has a resident flock of parrots, which is quite interesting that I didn't know about. Should I be pointing here? There? Yeah, and this one is really cool. So one other problem to think of is when you search for something visually, it really answers the problem of like, well, I don't know how to describe this thing, or I want not exactly this thing, but something similar. So in this case, you're pointing your device at a pair of jeans, for example, and you get suggestions for jeans that look similar. The same can be applied to shoes or any kind of items of apparel, furniture, etc. So I think this is going to be really, really interesting and really exciting. Okay. I think we got a bit of a internet lag. It's okay. So then, moving on to AirCore and tying these pieces together, if Lens is the visual browser for the world around you, AirCore takes it sort of to the next level or adds an additional layer onto it and makes everything that you search, everything that you see around you actually be interactable with. So in this case, you've got, I think it's Da Vinci, lady with the ermine, and the device is able to detect that, yes, it's a painting, that it's this particular painting, and is able to give you contextual, interactive, relevant information in the context of your experience such that you actually understand the process by which the painting was created. How, like in the first version, it looked quite different, then there's a revision, and there's the final version. So this is why AR is so powerful. The way this works is really interesting, and it has a couple of key components. Obviously, motion tracking is one of them, so the device actually knows where you are and can track you throughout the experience. Lighting estimation is really, really crucial as well, so that basically the device can detect the lighting changes. The GIF is quite cool, but it's not working, so you just have to use your imagination. So what happens in the GIF is that basically the light turns off in the room, and the creature is able to react to it getting dark because it understands that the lighting has changed in the room. Environmental understanding, equally as a GIF here that's not loading, but the idea is that the device is able to understand actually what is a table, what is a wall, so that you can position objects directly onto those physical spaces. So virtual objects can be placed on physical spaces. Okay, that's great. This works. Yeah, so this is just a fun example of kind of piecing these things together. This actually shows quite a cool, this is actually both across iOS and Android. So this uses all of the above mentioned kind of AirCore fundamentals plus what we call cloud anchors and multiplayer. So cloud anchors basically means that you can have a room scale experience whereby you can leave an object like this game and come back to it half an hour later to finish it. And you can have a multiplayer experience. You can have two people interacting at the same time with this game. That's really cool. And just some examples of how brands and companies out in the wild are already starting to use AR in this way. And I think it's important to say that a lot of these use cases are just scratching the surface, and it's much more around experimentation and understanding what works and what doesn't. But it's solving some pretty specific problems already. So if you think about, buying a car and using the car configurator online, which typically looks like what you have on the left, kind of unwieldy, not very inspiring, to having something like on the right with Porsche and having this be directly in your living room, and then more so having it basically drive on a road and kind of see it in action. It's just a way more immersive way of experiencing something. And then furniture is a really, really interesting example too. And I think if you think back to Lens, the user journey here might be that you've searched visually, you use Lens to identify a certain object, like a chair. And you either want that particular chair or you want a similar chair. Let's say you want a similar chair. You identify a similar chair through first lensing something. And now you're able to place that chair in your living room and actually understand what it looks like in your space. So the user journey becomes a lot more complete from simply having an object that you can place in a room. That's kind of been, one of the foundational use cases with AR, to actually first being able to get inspired kind of further up the funnel about a particular object and then being able to interact with it. And yeah, in terms of brands using AR, this is a really fun example, one of my favorites. It's basically Ivanov is jumping out of a painting, and this was done by Kiwi, the footwear brand. And they're having a lot of fun with kind of experimenting with new kind of AR use cases and basically AR ads. So with that, I hopefully give you a bit of a glimpse as to how we think of making technology, first of all, work more like we do, and give us a few more superpowers. I think there is some time for questions, right? If we do, if there are any questions. I guess these are not the questions. Live question. Is there a mic? Is there a microphone for live questions? No, I think this gentleman there had a live question. Maybe you can shout.
So just to, I'm a creator of content for,
Yeah.
for augmented reality. Yes.
Hello, my name is Tommy Ibsen. I come from World for Story. We do content for augmented reality. So just, it would be interesting to know, so in what time, like, how far are we to, I make, some content, 3D, like motion capture, 3D character. I put it on Google Drive, and I have some kind of connection to Google Maps, and I'm able to place it there so everybody can access it. It's just, can you give us, like, because that's one of the things that's hard to figure out is, like, how far are we?
Yeah. I think you mentioned quite a few things there that are like challenging in their own right. I think the first one is going to be 3D asset creation. That's kind of a big challenge in its own way. So 3D asset creation is scale such that everyone can create 3D assets easily, and then being processed, also with low latency and kind of high bandwidth. 5G is going to be really important for that. So that's going to come in a year or two. So I think you'll see a lot of that already starting to happen with 5G, so a year or two from now. But on the tech side, the 3D asset creation is going to be the key thing to solve for. What are the plans? Yeah, I think I'm not sure by what's meant by ecosystem, because in a way, the Google ecosystem, the way we think of is basically everything Android. So obviously the Android ecosystem is the way we think of a AR VR ecosystem. And mixed reality, I think, is inevitability in some way. And already you see this with all of the kind of HoloLens devices and Microsoft devices. We've announced an experimental set of features for Daydream, whereby you can take the Lenovo Mirage headset, which is all-in-one faceplate and 6 DOF controllers, and you are able to see the real world and equally have an kind of a AR experience within it. So mixed reality is inevitable. And as for the ecosystem question, that's really how we think about Android more broadly. Are there any more live questions? No. Okay. Then I think it's lunchtime, no?
Much.
Thank you.